So the next topic that we will be doing is complex numbers. In this, we will be looking at how exactly the form of about right now is gonna separate into two different parts. We look at that later, but let's see what am I talking about really right now. So for that, so this equation is what we have for now. So we'll be looking at it and understanding it. So x equals a plus bi. So a and b over here are real, but that is if the discriminant is less than 0. So we'll have to look at it. So this is the any form, or I would say any number of the form a plus bi, and of course iota equals under root minus 1 is of course called a complex number. So we have to notice that all real numbers can be written as complex numbers by choosing the b as a 0, and in special case when a is 0 it is called a purely imaginary number, right? We have a number form of b iota. So what I said was the two parts of this equation, which is again over here, but you can look at that also. So just z plus a, z equals to a plus bi. So when I say z equals to a plus bi, a plus bi has two, I would say two variables, which is a and b. Iota is a imaginary number, and we looked at that in last video. So a is the real part of the z, and b is the imaginary part of the z, which is real, which is written like this, and imaginary written like this. This concept is really very small, so let's quickly get through this. It says, for example, z equals 2 plus 3. So this is the format that we looked at. Let me just write it, or you can already tell me not write it, and I'll show you where it is written. You guys can look at it over here. It simply says z equals a plus bi. So z equals a is 2 plus b is 3 and I is iota, of course. Then the real would be the a, right? A is the real one, which so it is 2. And imaginary will be the b, which is 3 in that case. So imaginary of z would be 3. Let's look at another one, which is z equals minus under root 2 iota. So the real would be 0 because we do not have anything here, this part. We don't have anything over here. So that's why this will be 0. And imaginary would be this whole point from here to here, because that is before the iota, and that is the b. So imaginary would be minus under root 2. Now let's look at the complex conjugate. This is really important to look at that for sure. So let me just get through that really quick. So complex conjugate. Complex conjugate means it is like, I would say, the opposite in that sense, if you understand. So if we have z equals a plus bi by iota, the complex conjugate, the complex numbers conjugate is called the complex conjugate. So of this z, which we have, complex conjugate of this z equals a plus bi would be the opposite. So what is the opposite in this case? In this case, the opposite would be, so it would be a minus b iota, because we'll put the opposite sign because it's the conjugate, and we'll write it as this instead of the z simply. So the real part is gonna be z, complex conjugate of z would be equal to the real part of the conjugate of z, and imaginary part of conjugate of z would be equal to the imaginary part z, and but it'll be minus imaginary z, not just that, because it has a minus the opposite sign, because that is what changes when you have a complex conjugate. So for example, we have z equals to 2 plus 3i. So now z conjugate becomes 2 minus 3i. This is an exercise which you guys can solve and try to do. I would recommend to try at least like a few questions, or at least I'm not telling you to all, like just try this one. Like just try one of these. This one you can try. So after that, let me the third question. Just try to do this also. Just try to analyze this. And from the third question, just do A part, and then just do this, and then just do maybe this. So that will be perfectly enough for that. And let's look at some more questions. For the fourth part, just do the both. Very quite good analytical questions. And with that, we'll be done with the next B part of complex numbers as well.